Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at previous year questions of physics asked in medical and engineering exams in India. Today we are looking at a very important chapter in the physics syllabus for these exams. The name of this chapter is Laws of Motion. This is the same chapter that is taught as the 5th chapter in the grade 11 syllabus for CBSE. So that chapter deals with Newton's laws of motion, how things move in an inertial frame of reference and in non-inertial frame of reference. You talk about friction, you talk about various cases with pulleys and inclined planes, etc. So we're going to be looking at some of the many important questions that are asked in this chapter. So let's move on to the first question. The minimum velocity in meters per second with which a car driver must traverse a flat curve of radius 150 meters and coefficient of friction 0.6 to avoid skidding is 60 meters per second, 30 meters per second, 15 meters per second, 25 meters per second. So in this question, you've seen that a person is driving a car along a flat curve and he doesn't want to skid on it, but he wants to go as fast as possible. So which of these velocities must he travel in order to reach that actual speed without skidding? So over here you have a circular curve. It's a flat curve and it does not have any tilts or banks, and it has a radius of 150 meters, and then the coefficient of friction of that road is 0.6. So how do you find the Vmax along this curve? So the Vmax along this curve is given as mu times r times g, the whole root. Mu stands for coefficient of friction, r stands for the radius, which is 150 meters, and g stands for acceleration due to gravity, that is 10 meters per second squared. So on solving this, on applying the values, you get 0.6 into 10 into 150, all of that under a root. You have 6 times 150 under root, so 6 times 150 gives you 900. So square root of 900 is the correct answer to this question. The square root of 900 is 30. So therefore option B, 30 meters per second, is the correct option for this question asked in 2002. Let's move on to the next question. A lift is moving down with an acceleration A. A man in the lift drops a ball inside the lift. The acceleration of the ball as observed by the man in the lift and a man standing stationary on the ground are respectively. So you have G, G minus A, G minus A, G minus A, G. These are the four options. So this question deals with objects falling inside the lift. So inside a lift, which is moving with an acceleration A, the acceleration at which an object falls will differ based on the direction of acceleration. So in this case, the lift is moving with an acceleration A, and it has a man inside, and then he drops a ball, and this ball is moving with acceleration due to gravity, that is G. But since the man is also moving with an acceleration A, to him the acceleration will be G minus A, because he is moving with an acceleration A, so therefore you have to subtract that from the acceleration due to gravity. So the acceleration observed by the man in the lift is G minus A. And if this setting was on regular ground, so for example, if a man is on the ground and then he drops a ball, and if this ball is falling freely, then it goes with an acceleration G. So therefore, G minus A and G are the correct answers to this question. So therefore, option C, G minus A for case 1 and G for case 2, is the correct option for this question asked in 2002. Let's look at another question. When forces F1, F2, and F3 are acting on a particle of mass m such that F2 and F3 are mutually perpendicular, then the particle remains stationary. If the force F1 is now removed, then the acceleration of the particle is one of the four options. So let's look at an illustration of what the question actually says. We have a particle of mass m, a force F1 is acting, say, in this direction, and then you have two other forces, F2 and F3, which are acting perpendicularly. So let's say if this is the scenario, so this scenario sums up all the requirements of our question, and the most important part of this question is that the particle remains stationary when three forces are acting on it. So when does a particle remain stationary? Either if there is no force acting on it, or if there are balanced forces acting on it. So here, since the particle remains stationary, F1, F2, and F3 are balanced forces. So since F1 is in this direction and F2 and F3 are in the other direction, you can write F1 as the resultant, as the sum of F2 and F3. So you can see that F1 is equal to F2 plus F3. Now if we remove the force F1, there will only be F2 and F3 acting on it, and their resultant force will make this particle move. And so the acceleration of that particle will be F2 plus F3 divided by the mass. Since F2 plus F3 is equal to F1, you can write that as F1 divided by m. So the acceleration of that particle is equal to F1 divided by m. If you look at our following options, you can see that option A is the correct option for this question asked in 2002. Next question. One end of a massless rope which passes over a massless and frictionless pulley P is tied to a hook C while the other end is free. Maximum tension that the rope can bear is 960 newtons. With what value of maximum safe acceleration can a man of 60 kgs climb on the rope? So in this setup, let's say that there is a man here and he's preparing to climb this rope, which is attached to a hook. Now, in this question, what we are asked to find out is the maximum acceleration in which the man can climb this rope in order to avoid breaking the rope. So whenever you have ropes, you always have tension. So in this question, the maximum tension is given as 960 newtons, and the weight of the person is 60 kg. So let's consider the mass of the person to be 60 kg and the acceleration due to gravity is given as g, which is 10 meters per second squared. So when you take a pulley, take a rope that is passing through a pulley and connected to a hook, and you try to climb it, your weight is acting on the rope, and also the force that you exert is also acting on that rope. So the tension of the rope will be equal to both of those, the sum of both those quantities. So here you can write that the tension will be equal to 60g, this is the weight, plus 60a, which is the force exerted by the man while climbing. So from here you can arrive at the equation T minus 60g, that is tension minus weight, is equal to 60a. So as you can see, the force is acting downwards here, so therefore the tension must act in the opposite direction. So T minus 60g is equal to 60a. So we need to find the acceleration here in which with which the man goes up. So we are taking 60a to one side and all the other quantities on the other side. Now, tension here, in order to find out the maximum acceleration, we can take tension max, that is T max, that is equal to 960 newtons. So in the equation, you can write 960 newtons minus 60 times the acceleration due to gravity is 10 equals 60a. So 960 minus 600 equals 60a. So 960 minus 600 will be equal to 360. You can just do that, but then it would be waste of time. So 0, 6 minus 0 is 6, 9 minus 6 is 3. So 360 equals 60a. So therefore, the value of the acceleration is equal to 360 divided by 60. Zeros get cancelled. 6 goes into 36 6 times. So the value of the acceleration is equal to 6 meters per second squared. So this is the correct answer to this question. So in the following options, you can see that option B is the correct option for this question asked in 2002. The acceleration, the maximum acceleration by which the man can climb the rope is 6 meters per second squared. Here is the final question of this episode. A light string is passing over a smooth light pulley. Now, what does this mean? It means that the pulley and the string have no mass, and it connects two blocks of masses m1 and m2 in the vertical direction. So if the acceleration of the system is g by 8, then you need to find the ratio of the masses. So the setup is you have a pulley, and then a string is passed through this pulley, and then you have masses m1 and m2. The acceleration due to gravity is acting g on both sides. Now, if one of the masses is heavier than the other, then that mass goes down, the other mass comes up. So if you had a force here, it would go down with m1g, and then this would come up with m2g. So both those forces are acting opposite. So how do you find the ratio of the masses? We can use the formula for acceleration of the two masses. So the acceleration of the system will be F total divided by total mass. So here F total, the resultant force, is m1g minus m2g, because m2g is acting upwards. So m1g minus m2g in the numerator represents force. The denominator is total mass, which is m1 plus m2. So therefore, you can write this as g times m1 minus m2 divided by m1 plus m2. So therefore, the value of acceleration is this formula. Now, what we're going to do is we're going to take g to the left-hand side, so it gets divided, so it comes in the denominator. And then on the left-hand side, it's m1 minus m2 divided by m1 plus m2. Now, we know the value of acceleration is g by 8, so that means g by 8 divided by g equals m1 minus m2 divided by m1 plus m2. So the value of m1 minus m2 divided by m1 plus m2 will be equal to 1 divided by 8. When you multiply that, you get 8m1 minus 8m2 equals m1 plus m2. So let's take m1 to the other side, bring m2 to this side. So 8m1 minus m1 equals 8m2 plus m2. So therefore, you have 7m1 equals 9m2. Taking the ratio, m1 divided by m2 will be equal to 9 divided by 7. So if you were to look at our options, option B, 9:7, will be the correct answer to this question. And we found that out by using the formula for acceleration of one of the masses in the system. So this system of pulleys is the vertical system, where a pulley hangs, and then you have masses attached by a light string, which is passing over the pulley. So 9 by 7 is the correct answer. Option B is the correct option for this question asked in 2002. So that concludes this episode of NEET JEE-Main. We hope you found this episode interesting. For getting more of our useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios, and hit that notifications button below the video to get more updates. If you want to access more of our videos on NEET JEE-Main Physics, please click the link for that playlist in the description box down below. So that's it, guys. Take care, stay safe, bye-bye for now.